This is section 11.3 on combinations. A combination is where you choose or select items from a group of items. Order does not matter. That is a big deal. You are just choosing or selecting. You need to pick 5 cars out of 10 or 3 people out of 4. You don't care what order they are in. You are just picking them. Now, no item can be used more than once because these are physical items or people. Once they've been chosen, they can't be chosen again. So for these first 3, we're just going to read through and decide if they are permutations or combinations. Remember, the big deal about permutation is that order matters. Combinations, order does not matter. So you got 6 students are running for student government president, vice president, and treasurer. The student with the greatest number of votes becomes the president, the second highest vote getter becomes the vice president, etc. How many different outcomes are possible for these 3 positions? Now, does order matter or not? Yes, it does, because person A being president and person B being vice president is a different order than person B being president and person A being vice president. And because order matters, this is a permutation. B, 6 people are on the board of supervisors for your neighborhood park. A 3-person committee is needed to study the possibility of expanding the park. How many different committees can be formed from the 6 people? Ask yourself, does order matter? No, it does not. We are just choosing these 3 people. It is a combination. C, Baskin-Robbins offers 31 different flavors of ice cream. One of its items is a bowl consisting of 3 scoops of ice cream, each a different flavor. How many such bowls are possible? Does order matter? No, you are just choosing 3 flavors of ice cream. It is a combination. The number of possible combinations, if R items are chosen from N items, is given by this notation. And let's make it a little bit bigger so you can see. That's NCR. That's N items, and you are choosing R items from that group. It looks a lot like this notation. That was a notation for permutation, but this is where order mattered. Order does not matter. We are just choosing these. Now look what the formula is. The formula has n factorial on the top, just like the p formula did, and it's got n minus r factorial on the bottom, just like the p formula did. But this also has an r factorial on the bottom. And the reason that r factorial is there, not that you really have to understand why it's there, the reason it is there is because with a combination, since order does not matter, this part right here represents dividing out the repeats. So this would be worthwhile putting on your formula card. Also, there is a button on most scientific calculators that does this for you, but if not, we're going to work these out by hand. So we have a 3-person committee needed to study the ways of improving public transportation. How many committees could be formed from the 8 people on the Board of Supervisors? So you're looking at this, 8 people, and we're choosing 3. You always need to have the bigger number out here in front. You're choosing 3 out of 8. It would be very difficult to choose 8 out of 3. So according to this formula, we are looking at 8 factorial. That's the top. It's going to be the first number factorial. The next thing that's on the bottom is the second number, 3 factorial. And what goes here is the difference between these 2 numbers. That's what n minus r factorial says. So just look right here, 3 from 8 is 5. These 2 numbers on the bottom will always add up to the top number. And then you're going to work this out if you don't have this in your calculator. And the way you work it out is to start to write the factorial. 8 times 7 times 6. And right now, I would get ready to write out 5, 4, 3, 2, 1. And I'm saying I really don't need to write that out because I recognize in the bottom that 5 factorial is going to cancel out. So I only need to write 876 because that is going to cancel out with that 5 factorial. And the bottom here is 3 times 2. You could right here enter in your calculator 8 times 7 times 6 and get that number and put it right here. 2 times 3 is 6, and then do whatever that number was divided by 6. That will work. You could do this directly if you wanted to, but you've got to put the bottom in parentheses. You could enter on your calculator 8 times 7 times 6 divided by parentheses 3 times 2, so you can do that directly. Or what I like to do is just do a little bit of reducing. So I know that 3 times 2 gives me 6. All that's left is 8 times 7 is 56. Now, depending on the size of the numbers, My way is not a great way either, because I'm going to have some pretty huge numbers or a lot of numbers to deal with. So you just have to look at the numbers and decide what you want to do. How many different 4-card hands can be dealt from a deck that has 16 different cards? This is 16, C4, and it is definitely a combination. We're just choosing those cards. We don't care what order they're in. So this is 16 factorial over 4 factorial, and the difference between 4 and 16 is 12 factorial. I'm going to write this out. 16 times 15 times 14 times 13, and as soon as I hit 12, what matches with this, I cross that out and I stop writing on the top, and this is 4 times 3 times 2. Now you can do some reducing right here or just type it straight in the calculator. I will do 4 into 16 is 4, 3 into 15 is 5, 2 into 14 is 7. So all I would need to enter on the calculator is 4 times 5 times 7 times 13, which is 1,820. December 2011, the U.S. Senate consisted of 51 Democrats, 47 Republicans, and 2 independents. How many distinct 5-person committees can be formed if each committee must have 3 Democrats and 2 Republicans? Now, it looks like this might be more complicated because we are stipulating it must be 3 Democrats and 2 Republicans, but it really is not. We just have to make a combination for the Democrats. There are 51 Democrats, and we want to choose 3. Republicans, there are 47 Republicans, and we want to choose 2. There were some independents, but we're not choosing them. And what we do with this is multiply these together. So 51C3 is 51 factorial, 3 factorial, 48 factorial, and I'm going to go ahead and finish this before I move over here. So this is 51 times 50 times 49. As soon as I get there, I quit because the 48 on down will cancel, and this is 3 times 2. You can do some reducing. 3 into 51 is 17. 2 into 50 is 25. And 17 times 25 times 49 is 20,825. Over here, this is 47 factorial over 2 factorial, 45 factorial, which is 47 times 46. As soon as I get to the 45, I quit and cross that out. Divided by 2 factorial, which is 2 times 1, but why bother writing the 1? Reduce 2 into 46 is 23. 47 times 23 is 1,081. We're going to multiply those together to get as a final answer 22,511,825 different committees can be made. A zoo has 6 male bears, so we're looking at 6 males and 7 females. 2 males and 3 females will be selected for an animal exchange program with another zoo. How many 5-bear collections are possible? So for the male situation, we have 6 males and we're going to pick 2. For the female situation, we have 7 females and we're going to pick 3. And we will multiply those 2 answers together. You may say, well, wait a minute, what happened to this 5 situation? Well, you've chosen the 5. You chose 2 males, you chose 3 females, which made a total of 5. So formula-wise, this is 6 factorial, 2 factorial, 4 factorial. I'll finish this out first. So this is 6 times 5. Quit writing there because the 4 is going to cancel out. Divided by 2. 2 goes into 6 3 times. 3 times 5 gives me 15. For the females, it's 7 factorial, 3 factorial times 4 factorial on the bottom. So this is 7 times 6 times 5. Quit writing there. Cross out the 4. 3 factorial is 3 times 2 times 1. I'm not writing 1 anymore. 3 times 2 is 6, so I can wipe those out with the 6 right away. 7 times 5 is 35. Then enter on your calculator 15 times 35, which is 525. And remember, if you have a calculator that does these right off the bat, that's great. You don't have to write this out and do all this canceling. You can just let the calculator to do the work. So let's look at some problems here, and on these you need to ask yourself, is it a permutation, is it a combination, or is it a slot problem? These are going to be mixed in together. It's going to be section 11.3, which is combinations, but it will also include some of the other ones from 11.1 and 11.2. So this is just a formula problem. It's just the formula to evaluate the given expression, which is what we've been doing for the past several slides. So this is 10 factorial, 6 factorial, 4 factorial, or type it into the calculator. So this goes 10 times 9 times 8 times 7. Quit writing with the 6. And then 4 times 3 times 2. And what I do is I look at the bottom to see if any of this stuff multiplies up to give me one of the bigger numbers, and it does. 4 times 2 wipes out the 8 in one big move. And then 3 goes into 9 3 times. So what's left is 10 times 3 times 7, which is 210. That's the evaluation on 210. This is another evaluation they would like you to do, so we just have to do it a little bit at a time. Let's do the 6C3, which is 6 factorial over 3 factorial, 3 factorial, which is 6 times 5 times 4. Quit writing and wipe out one of the 3 factorials. 3 times 2. 3 times 2 gives me 6, so this is 20. Now, 5C4 is 5 factorial. 4 factorial, 1 factorial, which is kind of silly, and this is just going to be 5, going to cross out, so it's just 5. Anytime you have this situation where the number out front is 1 bigger than the second number, your answer will always be the outside number. So pretend you'd wanted to do 10C9. Automatically, that will be 10. 6C5 automatically will be 6. So keeping that in mind can save you a little bit of time. Then I could reduce this. 20 over 5 is 4, so I'm done with that fraction. 82 factorial is 82 times 81 times 80, etc. But this is 80 factorial on the bottom. So stopping there and then wiping this out, I just have 82 times 81, which is 6642. Do the arithmetic, and we have negative 6638. So that's just an exercise in following the formula and doing the arithmetic. Another thing I ought to mention while we're talking about these shortcuts here is if you have any situation where these two are the same, like ACA is 1, 5C5 is 1, 10C10 is 1. And the reason for that is if you have 10 people, how many ways can you pick 10 of them? Just one way, you pick them all. Another one along those same lines is something like 5C0. 5C0 is also 1. So you have 5 people. How many ways can you not pick anybody? 1. You just don't pick anybody. So those are some little shortcuts that you might want to remember.